All right, our next presenters is team number 15, TED.
All right. Hi, everyone. We're Team 15. We're TED. I'm Zach. This is Paige, Annie, Nico, and Pablo. And we're here to bring you TED, the Translating Educational Device. So our goal is to create or have a product that teaches children a new language in a cute and cuddly package. TED helps your children learn new languages in a new interactive way. We decided to put this product towards children because they're the most adept at learning new languages. TED has 3 different teaching modes to give the most overall experience with learning languages, really hit it home with all these vocab words, and then as well as a game mode to interact with the child. Our customer is Professor Kia, and he wanted this product to help teach his child Persian. TED also, as well as Persian, also teaches 3 other different languages: Greek, Spanish, and French, as well as it works in English as well, where that's the native language that we're assuming here. And the bear, the way the teaching modes work, the bear will tell the child the word, and it will translate it for it. It'll be, so for example, we have the banana there, and if it was teaching Spanish, it would say that this is a banana. Banana in Spanish is plátano. Repeat after me, plátano. And then it will wait for the child to press the button. There's an onboard button here, and then the child will speak into the bear. The speech will get processed, and then it'll be told if it correctly pronounced it or incorrectly pronounced it, and then it'll move on. A little bit of a technical overview here. I'm going to start in the top left corner. We have an Android parent app. This is meant obviously for the parent, and this will be used to choose the settings, what language they want to learn, what type of teaching modes, etc. This communicates via HTTPS to an AWS instance where we have a DynamoDB database that contains all of our vocabulary words and all of the translations of all of those words, as well as statistics of how well the child is doing, etc. And those are also displayed on the parent application. If we follow down from the Amazon Web Services, that's connected via Wi-Fi to our Intel Edison chip. Inside this chip, we have our speech processing algorithm. We also, this is the heart of our project. So this has our teaching curriculum. So that's what it runs through. It runs through all the lessons. This is also where we take in the input from the microphone, as well as our button to start recording. And then from there, moving down, we connect to the front-facing tablet, what you saw in that picture earlier. That's where we display all of our images. That's where all the audio files come out of. And then those go out through several speakers. We also have all of our audio files stored on the Android device, and the communication between the Edison and the device is through Bluetooth. And then the rest, and all of this is powered by external battery packs that are connected via USB.
So I was in charge of the cloud and the software on the Intel Edison itself. So the communication between AWS and Edison is over MQTT. So what happens is the Edison will post a message, and then depending what the current settings are, we'll send the message back to the Edison, which will update it with what the current topic is, what the current settings are. And then communication between the Edison and the tablet is done over Bluetooth. We send messages back and forth depending on what is happening. So we send like the name of the image and what the tablet is supposed to say. And then we store all of our data on NoSQL databases that are stored on the cloud. And that's basically it.
So I had 2 lead roles in this project. One of my first roles was to consult non-engineering experts, including people in the College of Arts and Sciences who are experts in foreign languages, and the School of Education, so we could learn how children develop. In this way, we were able to make our product even better. I also developed a streamlined process using Audacity, it's in the picture software-wise, which allowed us to record many people that we recruited in under 2 minutes per language for all of our vocab. So then Pablo will talk about our speech to text and how he was able to use that data to train that engine. In addition, I designed and populated a PCB where our Intel Edison lives, And I also worked on the rest of the hardware, so the peripherals like the push-to-talk, microphone, making sure the power system and battery worked, as well as the bearer and casings.
Hi, I worked in the speech recognition. So basically, TED is able to recognize 5 different languages: English, Spanish, French, Greek, and Persian. These were specified by our customer. And the way the bear works, it uses 50 vocabulary words. So the speech recognition was worked around these 50 vocabulary words. Each language has at least 75% accuracy with about a 0.09 second delay time. And we used over 6,000 recordings to train the speech recognition software. And here are some of the graphs that just show how the speech recognition works. So basically, Persian's the most accurate. Greek is the second most accurate with at 80%. French, English, and Spanish are both around 75% accuracy.
I worked on the parent Android application. The key part about this is you don't want a child going in to the bear and saying, oh, actually I want to learn about food and I want to learn in Persian, when before they were learning in a completely different language. So that's not very helpful. So we removed all of those settings to a parent application, so the child does not have access to any of that from the actual bear. So as you can see, these slides show the login. The second image shows what the settings are currently in AWS. So they're all pulled down from the database. And then the third one is how to change the settings, and that updates AWS and will update the bear as well. Another key component of the parent application is be able to track metrics and see how well your child is learning. So you can see the first bar is actually the percent of the language known, so that's a progress bar. Currently, the child does not know any English. They have to know the word in all 3 of the teaching modes in order for it to be considered known for that language. You can also click on a graph for each of the teaching modes to see the pink is the words that have not yet been covered in English, so they haven't gone over that in their curriculum. The purplish color is the known words, and then the turquoise is the trouble words for the child. And so that as a parent, you can also know what those words are, and you can work with the child individually. When you click details, you can actually see which words the child knows and which ones they're having trouble with.
I worked on the front-facing tablet application here. Like I mentioned earlier, this is connected to the Edison via Bluetooth. And then this is also used in the initial setup phase of the bear. This is to connect your Edison to Wi-Fi is through this tablet application. And so there are 2 modes here in the front-facing app. There's the learning mode, where the bear will speak to the child and it will interact vocally with the child, where it teaches them or it tells them the word and then has them identify the word in the other language. And etc. And then I mentioned we also had a game mode that reinforces the words that were learned throughout an interactive game. So as you can see, there's a grid of 6 photos there. The bear will tell it to please select the word in whatever foreign language that they're currently learning. So they have to remember what that word is in English and be able to identify the picture, just to kind of actually get some interaction, just more than just speaking to the bear. And I mentioned earlier, all of the recordings the voice of the bear is all on board the tablet itself. What's sent over from the Edison via Bluetooth is a string of what exactly needs to be displayed and what exactly needs to be said. And then these are all played out through speakers that are inside the bear.
And here's our demo. So we're going to go through some of the teaching modes.
One in Greek is Emma. Repeat after me. Emma. Emma. Good job. How do you say banana in English? Banana. Good job. How do you say cookie in Greek?
Kuraki.
Good job.
So as you can see, the bear is able to recognize the people speaking. There are other features that we didn't get to show because of time constraints, but if you want to see everything the bear can do, you can come visit us when we're demoing later.
So we also had a pretty successful customer installation. Unfortunately, we were not able to test with any children, but I mean, I feel like I was kind of a child testing it, so it's fine.
Okay, and as a conclusion, I think TED has a great potential to teaching kids a lot of different languages. So our main issue is having this like language barrier in the current state of the world. There are a lot of expanding cultures, and we hope that TED will be able to expand where languages can go and where they can take people. And TED is also open source, so there's room for developers to add new languages or new words, or even add like subjects like math or science. And we'd like to thank everybody in the ECU department, all the people that helped us record. Thank you, and that's it.
So you're using Intel Edison for the translation API, is that correct? Why did you decide on Intel Edison versus Google or Bing or other
No,
translation?
the speech recognition doesn't use Google Translation. It uses CMU Sphinx. It's a speech-to-text toolkit. So we chose that because it's user independent, and it's actually not like a API. It's installed in the Linux. It's running on Linux. So we don't need to connect to the internet. It's all done on the Edison.
So then the Intel Edison is the actual compute module, so kind of like Raspberry Pi, but it includes the Bluetooth and Wi-Fi inside of the about quarter-sized thing. And also, since we're in the Intel Cornell Cup competition, we had to use an Intel processor.
And also, since we only have a set amount of words, instead of actually actively translating them as we need them, we already have all the translations saved already to a database.
What accounts for that probability of correctly or incorrectly detecting a word for the different languages?
So we gathered a bunch of recordings and we tested on our program, and what we got as a result is about like 75% of the words that were spoken by all the people we recorded were recognized correctly.
And why is it different for each language?
Because there's different, phonetically speaking, I mean, every language is different, so the languages were trained for certain, the way that it's affected is because of the training quality. Some of the languages had better quality recordings than others.
And if you included more than 50 words, would those probabilities change?
Yeah, they would. It has to be retrained, and everything has to be re-optimized.
So I noticed a little bit of awkwardness in actually interacting with the teddy bear. You're looking off the side a little bit. Can you discuss any of the difficulties you had with developing that interaction and maybe cutting down on latency between speaking time, etc.?
I mean, one of the things that we actually added between the time that we recorded the video and today is a beep, so you know after the time you push the button, there's a little bit of latency between the time it starts recording. So it beeps before you can actually start saying something, so that's why I was actually looking at a computer that was saying it was actually recording now, so that's no longer an issue. Another thing is because we had to use a onboard chip and we couldn't actually just put everything on the tablet, that definitely caused some latency. So ideally if we were going to optimize this product, we would probably put everything on the tablet, which would make up for a lot of time of communication between the Edison and the tablet and AWS and things like that.
So there's a communication gap between the tablet and the
Yeah,
device.
yeah.
That was over Bluetooth.
Okay.
One question, both here.
Was the communication gap a customer requirement?
Yes.